Hello. This is a second video on the discussion of the bullwhip effect. In the previous video, we saw what happens when a company information flow is expedited, and therefore we don't have any issues with the flow of the material or the inventory levels. Now we're going to modify our simulation model to include more realistic situations in which we have delays of the information, delays in shipments, and we're going to measure the effect of that for a typical company that does not make more adjustments to their processes because of these delays. So let's check the new model. Hello, this is again Vensim, and in this case we have an equivalent supply chain model in which we have the inventory for the retailer, for the wholesaler, inventory for the manufacturer, and inventory for the raw materials. As well, we have the flow for the demand, the replenishment of the inventory for the retailer, the replenishment of the inventory of the wholesaler, and the replenishment of raw materials for the manufacturer. However, the model is different because now, instead of computing the retail replenishment based on the demand, now the arrows representing information depend on the retail inventory of what we currently have in hand and a goal that we have. So what we're trying to do is to go back to that inventory target. However, there is an effect on the delay. So essentially the computation of how much to submit to the retailer is the difference between the goal and the current inventory. So if the goal is, for instance, 200 and the current inventory is 150, it's going to compute to submit or to ship 50 units to go from the current 150 to the target of 200. And we do that for the wholesale inventory shipments. We have the same structure with the information taken from the wholesale inventory, the inventory goal, and the delay. And we have exactly the same structure with the inventory at the manufacturer, with the inventory goal, the current inventory at the manufacturer, and the delay of the shipments. Now, the assumption that we have is that the delay from the wholesaler to the retailer is not that large. We can see that the value that we have is 2, and this would be 2 days. And that reflects a typical behavior in which the wholesaler do not ship every day inventory to the retailer. It happens every other day. The wholesaler is replenished itself by visits by the manufacturer once a week, every 7 days. And finally, the manufacturer, whether if it's raw material or the final inventory product, the available inventory is available at the manufacturer every 21 days. Now, in the case of the manufacturers, this is the only entity that actually manufactures or produces something and need to transform it. We can think of these 21 days of delay as a consequence of the setup of the machines. Think about if you have a process, a manufacturing process, you need to transform something, and it takes you 30 minutes to produce, to start the production. Because you're changing the setup of the machine, the temperature or the tooling or something else. And if you have that situation, you will, once you have the setup, you will want to run a long enough production run to cope with the fact that you spend 30 minutes just setting up the machine. Now, naturally, maybe, or depending on the nature of the market, of course, but probably you will want to run more than the 30 minutes it took you to set it up. If you have a product that has very small margin, it's a commodity, and the setup is complicated. Then you want, since you have very little margin, you need very long runs in order to cope with the cost of setting up. In the glass industry, for instance, for construction, it typically was needed a couple of days maybe, or a little more than a couple of days, just to set up the machine. And the competition is hard. The product has very little margin, very little differential price opportunities, and therefore the runs have to be very long. So it could be that for some types of glass, depending on the thickness and the color, you may have runs that only happen once every 6 months. So the delay that you see here as 21, in a case like that, would be 180 days. And again, that obeys to the economics of the production. So as well as the information flow, as we have seen. In the case of the relation between the wholesaler and the retailer, in the case of the wholesaler and the retailer, this relation, the delay is 2 days, and that has to do more with the practicality of complete full load trucks to make the most efficient use of transportation, and that's again typical. So because sending a truck that is not fully loaded would make both either the wholesaler or the retailer to incur in higher cost. So the economics again, as well as the information infrastructure, would affect how these decisions are made. So what happens when we run the simulation? We can select the behavior of the retailer and its demand. And now we have a problem, because the demand remains at 50 and then changes at the moment t equals 400 for days. It duplicates to 100 units from 50 to 100. And you see, to begin with, the level of inventory at the retailer is fluctuating somewhere between around probably 60 to 80. And then the behavior of the same inventory fluctuates from 40 to around 90. And the reason for that is just the delays, these 2-day delays. Notice that the demand remained at 50 first and then 100 later. What happens with the rest of the supply chain? Let me see if let me move that here so you can see better that change. I could probably make this a little smaller. Yeah, I'm sorry. This looks better. Okay, so there you go. You have the change at 400, and then you have the behavior of the inventory. The blue line here represents the demand, and it's 50 every day for the first 400 days until the first moment of the day 401. The demand jumps to 100. Now let's see what happens with the wholesaler and the retail shipments. It gets complicated. Now the blue line represents the level of inventory, and the level of inventory drops to 0. And what happens when the inventory drops to 0? If customers go there, they will not find product. Here, you're already losing sales, or people have to wait for the product. And notice again that the demand has not changed. The demand is still 50, and you are forcing the inventory to drop to 0 at the retailer, which is not good. No, actually the shipments to the retailer are 0. Sorry. The wholesaler inventory is now dropping very low. Let's just isolate that one. Let's just compute the, there you go. This is the inventory of the wholesaler. Notice that again the demand is only 50, but now you need to ship 3,000. You need to ship around 6,000 here, and then consume it over long periods of time until you ship again. And this is a typical behavioral supply chain with bullwhip effect, which talks about the variation keeps increasing as you walk down upstream on the supply chain. What will happen with the inventory at the manufacturer? Well, that's a dramatic change, because now you have to produce around 80,000 units. Remember again, you're only consuming 50 per day. So you have inventory for over 1,000 days before you need to reduce to run another production day. And if it's product that is susceptible to be obsolete, to get damaged in the warehouse, this creates all sorts of problems. So the bullwhip effect is very costly for companies, and it's very important to try to avoid it. And this is only due to this example is showing you just the effect of the bullwhip effect based on one single case or one single cause, but there could be many causes. Here you have the shipments from the raw materials. The raw material people will send almost 4,000 or 4,000 units, and then they're not going to send anything else for a year, which is not easy. It is not convenient for them, because in order to submit 4,000 units, they need to install a plant that can manufacture 4,000 units in a short period of days. Even though the consumption, the real consumption, it only happens every 50 units every day. So it's a lot of capital invested in order to be able to respond to these needs on time when the supply chain need it. But actually the supply chain need seems a little bit artificial, and they are only generated by the delays of information, or the delay of the setup of the manufacturing processes. So whereas each one of the parties are trying to maximize the results by having a full load truck or having long runs after a long setup in the manufacturing process, the consequences are that there are other costs that we consider to be mandatory when they shouldn't be mandatory, when we have to make these large investments in manufacturing capacity that is not used, like is in the case of these raw material shipments. So we're going to have to learn how to deal with that, and we're going to discuss that in a moment.